Working with data that has a lot of times and dates in it will always be tedious. It doesn't matter what tool you use, it will always be slightly annoying to work with this data format. Thankfully, the tidyverse has the Lubridate package, which makes it at least a little bit easier to work with times and dates. And in this video, I give you a little introduction into Lubridate so that you know how to work with time and date data. So with that said, let's dive into our studio. In my quarter file, I already have a code chunk that loads the tidyverse and also gets the flights dataset from the NYC Flights 13 package. And if we execute this code, we see that this dataset is actually quite large. It contains a lot of rows in it, and all of these rows relate to flights that left New York City in the year 2013. So here we have a column that says year, month, day, and then it says departure time, scheduled departure time, and so on. And with this data, we want to create a chart like this that shows you the number of flights in New York City in 2013 via a heat map. And here we can see that for each week of the year and each day of the week, we have differently many flights on a given day. And what we can really tell is that there is one day of the week that has much less flights than all the other days of the weeks. That's because the color is much lighter here, and this indicates that the number of flights is much lower in that case. So that's the kind of thing you could see by creating such a heat map. But of course, you will need to get the aesthetics for this heat map first. So you need to compute for each day that you have inside of the data set. You need to compute which week of the year does this correspond to and which day of the week does this correspond to. Here it says that the 7th day of the week had less flights than all the other days. But this information is actually a bit ambiguous because depending on where you are in the world, you count these things differently. For example, in Germany, the week starts with Monday. So therefore the 7th day is Sunday. But in other parts of the world, the week starts at Sunday and therefore the 7th day is actually the Saturday. So that's something to keep in mind, and I will show you how you can make sure that you understand what day this number refers to. But that's something we'll need to do later. First, let us make these things here into dates. And once we have it as actual dates and not as 3 separate columns, then we can extract the week of the year and the day of the year. And once we are at that point, we can worry about whether this day of the week is Saturday, Sunday, or whatnot. To make things a little bit easier, let us first minimize this part here, and then let us also make this dataset a little bit smaller. First, we can grab only the first 5 columns of this dataset. Let's do that with select, and then we can dial down the rows by only grabbing the first 3 rows of a given month. So let's do slice 1, 2, 3 by month. And that way we have a small, nice data set that we can play around with and will actually see what happens with the time calculations that we'll do in the next couple of steps. So let's make sure that we arrange this by month. That way we have everything neatly arranged here in the order of the months. And then we can save this into a new data set. Let's call it flights subset. Now that we have this data set, we can create a new code chunk. And in there, let us take this data and create a new column that we call date. And in there, we want to use the makeDate function that can calculate the date of the year from these 3 columns. You see, if you look at the documentation of this, you will see that there is this function called makeDate. There's also this function called makeDateTime. It works exactly the same, but it has more arguments for hour, minutes, and seconds. But here we want to use makeDate, so this is why we only need the arguments year, month, and day. And conveniently, we have all of the information that we need in these 3 columns, so we can simply fill the arguments with the given columns from the dataset. And that way, we get a new column that has all of the date information. Also notice that this is a date column now. This is a special format that works for time data. We could create such a string here by using the paste function or the glue function to assemble all of these things into one string and then put this into a new column. But then this would be a character column and not a date column. But this date column has some convenient properties that make it nicer to work with them when you want to do time calculations. So let's stick with this one here. And now that we have a date column, we can really easily compute stuff like the day number of the year, whether it is the 300th day of the year or the 5th, it always works the same. Or we could compute the week of the year or the month of the year. All of these things can be computed using functions like Wday. So if you want to get the day of the year, you use the Wday function on the date column, so year day. And similarly, you can use other functions that are similarly named. You can calculate the day of the month by mday, or the day of the week by weekday, wday, or the week of the year by week. All of these functions are pretty conveniently named so that you can figure out what they do. And if you execute all of this, we have a lot of columns now. So let's select a couple of them. Here, let me just throw in a select call that gets everything from the date column to the end of the tibble. So here you see that this column now has the day of the years. The 1st of February is the 32nd day, but it is the first day of February. Apparently, this day was also the 6th day of the week, and this day was in the 5th week of the year. And now that we know how this works, we can do the exact same calculations, but on the full flights data set, so that we can count how many flights left in a given week and on a given weekday. So let's open up a new code chunk. In there, we can take our full flights data set and create new columns. Here we use the make date function again to make dates. So we put in year, month, and day again. This will give us the date just like before. And then we compute the day of the week and also the week of the year. And once we have that, we can simply count how often we had the day of a week and the week of a year. And that way we have all of the counts that we need for the data set that we want. So that is why we simply save this into a new variable that we call counts. Now to create the heat map, let us look at it again. This is what we're going for. We take our counts data set and then pass it to ggplot. And now we have to specify the aesthetics, and we can see here on the x-axis we have the week of the year, on the y-axis we have the day of the week, and for the fill color we have the amount of flights, and this is saved in the column n. And now to make these squares, we simply have to use a geom tile layer. And that way we get a lot of rectangles, which don't look that nice yet, but we'll fix that in a second. For starters, we can make sure that each tile has an outline, so let's put the outline to white. Then we can throw in a theme minimal to increase the font size and change the font family and also change the theme to something minimal. And then we apply chord equal, which ensures that we have an aspect ratio of 1:1, which means that the distance on the x and y axis are always the same. And that way we get squares instead of rectangles. Finally, the default colors from ggplot are not that nice for a scenario like this, and we can modify these things with a scale fill layer. And since we have a color gradient here, the layer that we need is scale fill gradient. And inside of this layer, we can use the arguments high and low to specify the colors that we want to use for high and low values of the counts. So here we use high and low like this, and then we get a much nicer plot. Now all that's left to do is to make some nicer labels. So let's use the labs function, and in there we specify that on the y-axis we don't need a label. On the x-axis we need a week label. For the fill aesthetic we use the flights label, so that n here becomes flights. And then we put in a title that simply says number of flights in New York City in 2013. Cool, with that we have a nice chart that shows you this nice pattern of one day of the week getting less flights than the other days. Again, because this day of the week number is ambiguous, let's figure out what these numbers actually represent. And the way to do that is to simply take our code from before, and then let's put this into a new code chunk. Let me make some room here, throw in a new code chunk, and then put this code in there. So that's our code from before. For now, let's get rid of the things that are not ambiguous. So let's remove this part here, and let's also get rid of this part here. And then if we execute this, we'll see that actually we have too many columns here. So let's grab only the date column and also the day of week column. And if we execute this now, then we get this data set here. Now, if we look at the Wday function, then we see that this function here has actually a couple of more arguments. It has label is false and abbreviation is true by default. So this means that if we set label to true, we probably will get something like a label instead of a number. We can actually check that this is true. And here it says true will display the day of the week as an ordered factor of character strings such as Sunday. That's what we're going for. So let's put in day of the week label and put in label to true there. But then of course we also need to grab this new column. So let's put this into select as well. And then we see that we get labels. These things are abbreviations now. So let's also get the full labels and put abbreviation to false. And once again, we also need to get the new column. And now we have all of the things in one data set, but you can tell that these things here now are the German labels, and same thing for the abbreviations. If you want to change these things, you can actually look at the Wday documentation again, and it says something like local, and in there it says sys.getLocal.lctime. And if I put this into the console on my computer, this may change on your computer. It may give you different output. it says de_de.utf-8. While this is pretty cryptic, we actually don't need to understand what this part means. We only need to figure out that this part here, I know because I live in Germany, that this means that we have German from Germany. There's also German from Swiss and Austria. In that case, this DE would be different. And if I want to set my local, or at least my local inside of the Wday function to something English, like English from the United States, then I can use en_US in here, and then I will get the English local. More precisely, the US English local. So let's try this out. Let's make some room for that here. Put this in there, make some room, some line breaks. And then with this styler package, we can reformat everything. So now the parentheses are reformatted. And now we can put in the new local that we want to use. So local is this part here, but here I replace this en_US, and I do the same thing here. Again, this UTF-8 may depend on your operating system. So just call this sys.getLocal on LC time, and then you will get the string that you need to change to the local that you want. And now if I execute all of this, you can see that these things are the English labels now. And that way I can see that the number 6 here by default refers to Friday. So therefore what we see here in the chart, the 7th day must be Saturday. So we know that on Saturdays there are less flights leaving New York City. Alright, cool. So now we have learned how to work with dates. Now let's also do some time calculations. Let's put in a new code chunk, put this in here, and then let's look at our subset dataset again. Here we can see that there's another column called departure time and scheduled departure time. So we might be interested in figuring out, okay, how much delay was there? And the natural thing to do would be to just compute a new column that we might call departure delay, and then simply subtract these numbers. And then if we execute this, we get a result, but we can already see that there are some weird numbers in here. It looks like here there were 44 minutes of delay, but actually if we look at this, if we look at the times and convert those in our head, this is 4 a.m. and 56 minutes, and this is 5 a.m. sharp. So really these are only 4 minutes of delay. Actually, it's 4 minutes early. So here we can see that this naive calculation of simply subtracting these numbers doesn't work because of course the hour system has only 60 minutes, but here this calculation assumes that after 460 comes 461 and so on, but of course 461 should be 500. So let's use this row as a kind of example row. Let's just get this here and then work with this to refine our calculations until we see that the result makes more sense. At least sense in the sense that it actually corresponds to the time calculations that we want to do here. So you probably know that there are always functions like as.character or as numeric. These functions help us to convert things from some format to a different format. So it is natural to assume that maybe we don't want to use integers here. We want to use some other format. And I've already said there is this thing called datetime. And if we look at this, there is as date and there is even as datetime. So we might be inclined to say, okay, maybe we just convert these things to datetime and then we do the subtraction. So let's try this. Let's put in the formatted departure time and the formatted scheduled departure time and then do the exact same calculations again. Let's see if this works. And now we get the exact same result, like we get this minus 44, but it says something like minus 44 seconds. This can't be right. We have already established that the difference should be something like 4 minutes, not something like it should be 4 minutes. And if we look at the formatted numbers here, you can actually see what's going wrong. You see, right now, both of these dates are on the 1st of January 1970. Both of these have the same. And if you do some calculations in your head, you will figure out that 456 seconds is actually nothing but 7 minutes and 36 seconds. And similarly, 500 seconds are 8 minutes and 20 seconds. So really what this as date time function does is it takes the number and then interprets this as the amount of seconds that comes after this initial date. For some reason, 1970 is just the initial date for this function. So once again, this is not the calculation that we want to do here, but it's easy to assume that this might go our way if we tried it with this datetime thing. This is actually what I tried to do first. I thought like, okay, this might be the easy way to subtract sometimes, make this datetime, and then hopefully it works. Turns out it doesn't, but I guess that's how you learn. But it turns out that this idea isn't completely wrong. We do indeed need to first make sure that we get date times into this column. But we really have to make sure that we make this into the correct dates and times and not just something in the 1970s. So let's use the make datetime function that we've already seen in the documentation, namely this one here. So let's get rid of this part here. And then we can see that we need to set the year, month, and date as the first three arguments. So let's do that. Let's do departure time and use make date time. And in there we use year, month, day as the first three arguments. And for the hours and minutes, we actually have to compute those from this column here. In this case, we need to do some integer division by 100. So this means the hours are departure time divided by 100. For this number here, this would give us 4. We are doing integer division here, so this is why we get 4 and not 4.56. And then the remainder, that's what this operator does here. The remainder gives us 56, and that's the amount of minutes that we need. And now we see that here we get the correct date. And then we can do the same thing for the scheduled departure time. Again, use make date time, use year, month, and day as the first arguments, compute the hours by integer division, and compute the minutes by the remainder. And then we have both of these things converted into date times, and all of the dates and times look correct now. Let's actually save this into a new data set. Let's call it converted times. Actually, we don't want to convert only the fourth row into this data set. Let's do the whole data set. And then we can always look at converted times and then put in slice again to look only at our dummy here. And here we can see that our code that we have left in here by accident, I actually didn't mean to leave it in, but now it is in there, so let's just deal with it. It actually shows us the 4 minutes delay, which is kind of nice. This works, but unfortunately we have to get a little bit more complicated because these -4 is not a nice format to work with. Instead, what we should do is to make so-called intervals from departure time and scheduled departure time, and then figure out how many minutes fit into this interval. While this sounds a little bit confusing and frankly more complicated, it will actually help you in the long run because it will save you some time of converting units and so on. So let's just go this route, and I hope that at this point you just believe me that this is the easier way to do it and the safer way for all of the time calculations that you want to do in the future. So let's get rid of this part here, and then we can use our converted times and calculate a new column. And first we want to compute this interval that I just mentioned, and this works via the interval function from the Lubrelate package. And in there you just have to specify the start and the end of the interval. And once you execute this, you will get something which is in the format interval. And with these intervals you can do really nice calculations by simply saying, for example, that the delay in minutes is the departure interval divided by the amount of minutes that you want. In this case, we want to divide this by 1 minute. So let's try to figure out how many 1 minute intervals, this one here actually gives you an interval, how many 1 minute intervals fit into the interval that we have. And that way you get another column. So let's select only those that are of interest to us. And then you can actually see that a departure interval is just what you expect. It is some interval indicated by these two lines here between a start point and an end point. And now if we look at our example from before at the fourth row, we see that we actually get the delay in minutes as -4. So we know that the departure delay was -4 minutes. So therefore the flight left 4 minutes early. Notice how this is different from the output that we have here. Here this said -4 mins. But now if I wanted to convert this minutes to hours, for example, I could imagine that I just reformat this column by using the hours function and then using this -4 minutes in there. And the idea that I would think is that duration would then be converted to something point something something hours. But let's check what happens. Now this is in hours here, but it simply took this -4 and set this to hours. This is usually not what we want to do. So this is why it's really easy to get confused with these calculations when you do it like this. And this is why the way to go with this is to use this a bit more complicated interval notation, but it comes at the advantage of you knowing exactly what you compute here and in which unit it is. For example, if you wanted to get the delays in some other unit, for example, if you wanted to get the delay in hours, you just divide the same interval by a duration of 1 hour or by an interval of 1 hour. Similarly, you can do the same thing for 10-minute blocks. In that case, you divide by a 10 minutes interval. Or if you wanted to do something like 1.5 minutes, you cannot actually stick 1.5 into minutes. It always wants integers. So in that case, you take the interval and divide it by 1 minute plus 30 seconds. And then if you execute this, you get the same amount of columns. But if you get all of the columns that you want, then you can see that's all in there. Let's just get rid of the interval. Let's just put in the delay in minutes. And that way you can see this always gives you nicely formatted results. And more importantly, you always know what unit this number refers to. And with that, we're done. Calculations with times and dates are always a bit tricky, but I hope that with this video, it became a little bit easier for you. Feel free to let us know in the comments if that's the case. As always, you can find all of this code in our blog. We'll put a link to that into the description of this video. And with that said, have a nice day and see you next time.